solving systems of equations. Systems of equations are sets of two or more equations that we solve simultaneously, meaning we solve them at the same time and we solve them together. The solution could be any point that works for all the equations involved. And we'll talk about the types of solutions later on. Linear systems contain an x and a y. Okay? In standard form, ax plus by equals c, dx plus ey equals f. Granted, a, b, c, d, or e, or f, they could be the same thing, but they don't have to be. One thing I want to remind you of is that the slope, because we're going to use slopes a lot with this graphing. We're not just going to find the 2 points and draw the line in between them, because that is not very accurate. The slope of this line is going to be negative a over b, and the slope of this line is going to be negative d over e. Okay? And if you were to solve for y, we would subtract the ax, that would make the a negative, and divide by the b. Same here. Subtract the dx and divide by the e. So that's how we get the slope. I think we've done that once before. Okay, here is a problem that we're going to solve by graphing. Okay. First, let's start by finding the slope of each line. So this slope is going to be negative a over b. So negative 3 over 2. The slope of this line is going to be negative a over b, or de, whichever you want to call it. What is it when it's not written? It is a 1. So your slope is going to be negative 1 over 3. Now we need to find another point that's on the line, okay? And we can go with your x and y intercepts. If this is equation 1 and this is equation 2, okay, let's find the x and y intercepts, and maybe one of them will be an integer. We want to work with integers when we're dealing with this type of thing, okay? Starting with the x-intercept with equation 1, cover that up. 2y is negative 4, so the x-intercept is negative 2. If we wanted to find the y-intercept, we can, but it's going to be negative 4/3, and that's not an integer. I don't want to deal with that. We just need 1 point. We got the slope. We can find the others. Equation number 2, we have x and y. Okay, the first one I see off the bat is my y. This one's the y-intercept. I called it the x-intercept earlier. My apologies. First one I see here is the x-intercept, because if y is 0, then x is 1. We've got the slope, and we can go from there. Okay, now graphing. I know this will be a little difficult to see. I'll try to use different colors. Okay. There's our axes, x and y. We'll make equation number 1 will be red, and equation number 2 will be green. So starting with equation number 1, let's plot the point 0, negative 2, and then use the slope, which is negative 3 over 2, so down 3 over 2, down 3 over 2, and then we can go up 3, back 2, in the same direction. Up 3, back 2. Okay, those are all on the same line, correct? Correct. So there's equation number 1. Let's see if we've got the solution in there yet. Let's go to equation number 2 and plot the x-intercept, which is at the point 1, 0. Now using your slope, there is the x-intercept. Now I'm going to go down 1 and over 3. Down 1 over 3. Well, I can see these lines are getting farther apart, so let me try going the other way. Up 1 and back 3. Oh, looky there. There is my point of intersection right there. Up 1 and back 3. Okay, and I do expect you guys to actually draw these lines, But once we find the solution, and the solution is this point right here, and the ordered pair for that would be -2, 1. Okay? Solving systems of equations by graphing is best if we know that we're going to have integers for answers. If we don't have integers for answers, I would much rather you use a different method. But this gives you an excellent practice with graphing lines, using the slope to move around and get the equation of the line or get the line drawn. Okay. Next one. Okay. Solving by graphing again. Okay, we can number the equations 1 and 2. We're going to use that for when we find our points. Next one, find your slope for each one. M equals -a, -8 over B. In this case, it's -1. So M equals +8. Here we've got your slope is equal to -3 over 2. Okay. Now for equation number 1, we need to find a point. And the fastest one I see is making x 0, which would be your y-intercept. -y equals 8, so y equals -8. And for equation number 2, we need to find a point. Quickest one I see again is the y-intercept, making the x 0. -16 divided by 2 is -8. Do we see something here? I hope you do. If you don't, then let's graph them. Okay, here is our coordinate plane. Make your x and y axes. Okay. For equation number 1, okay, for equation 1 will be in red again. Equation 2 will be in green again. Equation 1, plot the point, -8. Use the slope, up 8 over 1, okay. How about equation number 2? Oh, look, there's our point of intersection. You guys, I'm sure you're smart enough, you would have seen that. The solution is the point 0, -8. You guys would have seen it here, okay. But if you have to graph the lines, which you do when you solve by graphing, this is what you do. Okay. Types of systems. There are 3 types of systems. The type that we just got done seeing, where there is exactly one solution. The lines are intersecting. They are said to be consistent and independent. So if I ask you to classify the system, I want to see consistent and independent when you have a pair of intersecting lines. This is the type of solution. Another type, we have infinite solutions. These are coinciding lines, meaning 2 equations for the same exact line. These are said to be consistent and dependent. If it has a solution at all, it is consistent. If it has one solution, it's independent. If it has infinite solutions, it is dependent. Then the third type is no solution, okay? Parallel lines, and it's inconsistent. Okay. Let's look at some special cases when we're graphing. So when we're graphing, what can possibly happen? Here is equation number 1, here's equation number 2. When we're graphing, we're going to find the slope. M equals -a over b, so -2 over 5. And in this case, slope is -4 over 10, which you better reduce that. which is negative 2 over 5. Now, immediately, my interest would be, something would be blinking. I'd have a red flag go, because I've got the same slope. So that tells me immediately, if the slope is the same, I either have parallel lines or coinciding lines. So let's continue. Let's find a point. Okay. If I get the same point here, we have coinciding lines. One way to tell is to go for the y-intercept. We could do that, or we could go for the x-intercept. Because if they're coinciding, one of those is going to be the same. If they're parallel, neither of those will be the same. So let's go for the x-intercept. That's when y equals 0. Why am I choosing the x-intercept? Because I see this is 2 and this is 6, and I can divide 6 by 2 evenly, and that is 3. Because when this is 0, I've got 2x equals 6, so x equals 3. Same here, 4 goes into 12 evenly, so when y is 0, 4x equals 12. 4 times 3 is 12. So what kind of lines do I have? These are coinciding. And if we are to graph them, you don't have to graph 2 lines because it's just going to be 1 line. Coinciding are 1 line. Coinciding lines are actually just 1 line. Okay, so you plot the point we've got, 3, 0. There it is. And use your slope, negative 2 over 5. Go down 2 over 5. Okay, and then you can draw your line. Next one, I want to point out first of all, this is the assignment. Okay. This one, let's go with equation 1 and equation 2. Let's find the slope for equation 1. The slope for equation 1 is negative a over b. The slope for equation 2 is negative a over b. And again, my interest is peaked. Red flag going up. I've got the same exact slope. Tells me parallel lines or coinciding. Well, let's see which. Equation number 1, let's find a point. Okay. Equation number 2. If we go for this time the y-intercept, because I can see that 2 goes into 10 evenly. 2, if x is 0, y is 5. And then if x is 0 on equation number 2, y is 1. I've got different y-intercepts, same exact slope. These lines are parallel. There is no solution. Okay, and I did that without graphing, but we can actually graph these. I'll use a different color. My axes will be blue. Hopefully you can see them. Equation 1 will be red. Plot the y-intercept, which is 0, 5. Use the slope, which is negative 3 over 2. There is that one. Change colors. Go for green for equation 2. 0, 1 is the y-intercept. Negative 3 over 2. If I had used a ruler, I could have made them look much more parallel. But there they are. Okay, so no solutions, parallel lines, infinite solutions were coinciding lines.